Hey everyone, today we are going to talk about quadratic functions. And this stuff should all be review, but it is something that's important. Our new unit that we're starting is polynomial functions. The most basic of those is quadratic functions. So we're going to talk about those a little bit today. We have two forms of a quadratic function. The first one is the standard form. You'll see this at the top of the page. This is also on your note sheet, so make sure you have that printed out before you continue on with the video. Okay, so our first example here is to graph the quadratic function that's given there. Now this is in standard form, so a couple of things. HK would be our vertex of our parabola. And I know we talked about parabolas when we just did conic sections, but this is more application type problems with parabolas. So this first part is just a quick little review. This again is similar to the form that we used when we were graphing them. Before we had this 4p in here and those other things because we were doing the focus and lattice rectum and all of that. We're not going to be doing that in this particular form, okay? HK is our vertex. A tells us whether or not our parabola opens up or down. So if A is positive, it opens up. If A is negative, it opens down. So let's go ahead and go through the steps of graphing this this particular problem that we have here. So first of all, I want to find my vertex. Remember that your vertex is always going to be the opposite sign of what's here. So since this says -3, my vertex is at +3, and then because this is on the outside, I go the same direction as that. So my vertex is at 3, 8. Only because that's in parentheses do I have to take the opposite sign of that. The +8 means it's shifted up. Okay, the +8 means it shifted up. So my vertex is at 3, 8. So here is my vertex. Okay, again, you can look at the formula here, +k, or +8, right? So it's the same sign for the y coordinate. It's the opposite sign for the x coordinate. Okay? Okay, then what I want to do is I want to find one of my intercepts. Okay, I want to find my y-intercept and my x-intercepts. So to find the x-intercept, remember this is where we cross the x-axis. I'm going to set my function equal to 0. Okay, so when y is equal to 0 or when f of x is equal to 0, that's where I'm crossing the x-axis. So I have -2 times x minus 3 squared plus 8 is equal to 0. So -2 times x minus 3 squared equals -8. So what I'm doing is I'm isolating the x minus 3 squared term. If I divide both sides by -2, I end up with x minus 3 squared is equal to 4. Okay, so now if I take the square root of both sides, that x minus 3 squared just becomes x minus 3. And here, I end up with plus or minus 2. So x is plus or minus 2 plus 3. So you can think of it as 2 plus 3 and -2 plus 3. So it would be 5 and 1. So here at 1 and here at 5 are my x-intercepts. I also want to find my y-intercept. So to find my y-intercept, I don't have a ton of room here, But what you want to do to find your y-intercept is you are going to compute f of 0. So basically you're plugging 0 in for x and figuring out what that y value is. So I have negative 2 times 0 minus 3 squared plus 8. Okay, so negative 3 squared would be 9. 9 times negative 2 is negative 18 plus 8, so that would be negative 10. So I would go down here to negative 10. Now, I have plenty of stuff I need to graph at this point. Notice I didn't make a table or anything. All I did was found my vertex, my x-intercepts, my y-intercepts. One thing with parabolas, you know that the vertex is the middle of your parabola, meaning if you were to draw in that vertical line through that vertex, that is your axis of symmetry, which means your parabola is going to be symmetrical on either side of that. Right? So if you notice these two purple points, they're each 2 units away. Down here at 10, I'm 3 units away, so I know that I would have another point here that's also 3 units away from that axis of symmetry. Okay, and so from there then I'm going to be a really bad sketcher here, and I can draw in my really bad parabola. Pretend that looks pretty. It looks really bad, but I think you get the general idea of what that looks like. Okay, so when you're in standard form, you want the vertex, you want x-intercepts and y-intercepts. And that will allow you, that gives you enough information to graph it. Also, by looking at this, we knew that it was going to open down because A was negative. Okay, when we are given the quadratic in the general form, which is something that you have seen many, many times before, we find our vertex by first finding the axis of symmetry. If you remember, we use the formula negative b over 2a, right? That's the first thing that we use. And in using that, let's look first at this standard form. Remember that if A, same rule is true. If A is negative, it's going to open down. If A is positive, it's going to open up. Okay, so this particular parabola or quadratic function, the parabola opens down because A is negative, which means that I will have a maximum value. My maximum value is going to be at that vertex, and so that's what we're going to find. So to find the vertex, we have to do negative b over 2a. So whether or not it's a maximum or a minimum, whether it opens up or down, it doesn't matter. We're still starting off by finding negative p over 2a. So in this case, I have negative 4 over 2 times negative 1. So it would be negative 4 over negative 2. And so x is equal to 2. And now to find the y-coordinate of my vertex, I just plug that value back into the original function. Right, so now I'm going to find f of 2. So I have negative 2 squared plus 4 times 2 minus 1. So that would be negative 4 plus 8 minus 1. So negative 4 plus 8 minus 1 would give you a total of 3. So my vertex here is going to be at 2, 3. So 2, 3 is my vertex. Okay, 2, 3 is my vertex. Now that I have my vertex, I really go through the same process I went through with the other one. I'm going to find my x-intercepts, I'm going to find my y-intercepts, and I kind of ran out of room here. You should have enough room on your paper. I'm just going to write it up here. I first want to find my x-intercepts by setting my function equal to 0. So this is not going to be factorable, so I'm going to have to use either the quadratic formula or completing the square. So I'm going to go with completing the square. I'm actually going to get rid of that negative in front, so I'm going to multiply through by -1. And then I'm going to complete the square. So x squared minus 4x plus 4 equals -1 plus 4. So I end up with x minus 2 squared is equal to 3. So x minus 2 is equal to plus or minus √3. So x is equal to 2 plus or minus √3. So √3 is like 1.7, so you'd have roughly 3.7, so somewhere right around here. And 2 minus 1.7, so you have roughly about a 0.3, something like that. Those are my x-intercepts, and I'll write my y-intercepts over here. Again, you probably have enough room on your paper to write it below. Your y-intercepts, all you're doing is substituting 0 in, so you're just finding f of 0. So it would give me -0 squared plus 4 times 0 minus 1, so that would just be -1. So 0, -1, and we know that we can go over there as well, because remember, here is our axis of symmetry. And so if I were to graph that, here's my really bad graph, but you get the general idea. Oh, goodness gracious. Anyway, here's my graph. It looks, I think I went over too far with that, but it looks, I did go too far. It should be more over here. You get the general idea of what it's supposed to look like there. Sorry about my bad graphing, but. So again, with either form, you're going to first find the vertex, and then you're going to find your x-intercepts and your y-intercepts. Okay, I'm going to stop this video here. In the next video, I'm going to go through the application problems.